Hello everyone, welcome to this introduction of kinematics. We're going to start kinematics and we are going to cover the entire kinematics in bite-sized lessons. So kinematics is the study of motion, but here we are not concerned, we are not bothered about the cause of motion, as in we're only concerned about, let's say, the initial velocity. What is the final velocity? What is the time taken for an object to move from place A to place B? How much distance is the object covering? These are the things that we are concerned about. We're not concerned about what is causing this motion. So in kinematics, we are concerned about what is the acceleration, but we are not concerned about where is this acceleration coming from. When we start asking questions like where is this acceleration coming from? What is that thing? What is that physical quantity which is causing an object to accelerate? That means we have moved from kinematics into dynamics of motion. So kinematics is relatively simple. We're not going to be concerned about forces and all. We're just going to be concerned about the state of the motion, not the cause of the motion. I hope that's clear. So here is what we are going to cover in kinematics. We're going to start with motion in a straight line. We're going to see how an object moves in a straight line, how an object moves in a horizontal path or a vertical path, but the motion is always one dimensional. For example, if we throw a ball vertically in the upward direction like this ball will rise up, stop at a given height, and then start falling back again. Now, this entire motion going up and coming down is happening along one vertical line, a straight line. So this is what we are going to look at in one-dimensional kinematics. Why only vertical motion, or why motion in a vertical line only? We're going to consider things like a car moving on a straight road. It is accelerating at a certain rate. How much time will it take to attain a certain velocity? These are the kind of questions we are going to address here. Also, we're going to look at a few graphs like velocity time graph, displacement time graph, acceleration time graph, and so on. Then eventually, after we have covered the entire 1D motion, after we are comfortable with analyzing one-dimensional motion, we move on to two-dimensional motion. And within the two-dimensional motion, we are going to specifically focus on projectile motion. Something like this. Projectile is any object which falls under gravity. So if we throw an object, a point-sized object in this direction, this has two components of velocity, one in the horizontal, one in the vertical, and it moves along this parabolic path. This is what we are going to see when we move on from one-dimensional motion to two-dimensional motion. So that gives us a brief idea about what we are going to cover in this session. Now, this is the first session, so we are going to restrict ourselves to the introduction of kinematics. Moving on. So if I were to ask you whether this person sitting inside a moving train, is this person at rest or in motion? What would you say? Is this person at rest or in motion? Now, in order to say whether this person is at rest or in motion, we need to ask ourselves, what is our reference? Am I asking with reference to this person standing on the platform, or am I asking it with respect to the person sitting inside? So if I ask you whether person 1 is at rest with respect to person 2, the answer is going to be yes, even if the train is moving or even if the train is at rest. In both these cases, person 1 is always at rest with respect to person 2. But if I ask you whether person 1 is at rest with respect to person 3 as well, the answer is going to be no. Of course not. If the train is moving, that means person 1 is moving and person 3 is not moving. So person 1 is in motion with respect to person 3. That means the concept of rest and motion are relative. So whenever we talk about whether something is at rest, We need to ask ourselves, what is the reference frame? We need to know the reference point. It's not absolute. There's nothing like absolute rest and absolute motion. For example, if I ask you, is the ground at rest? You would say yes, of course. But think about it from a bigger perspective. Let's say you are analyzing the Earth from space. You would see the Earth is moving about its axis, right? It's rotating about its axis. The Earth is also moving around the sun. So the Earth is not at rest. How could you say that the ground is at rest? So that's why rest and motion are relative concepts. We need to ask ourselves, what is the reference frame? So let's get to know reference frames. It can be the reference point itself can be moving, it can be at rest. Sometimes the reference point itself is accelerating. So based on this, we classify reference frames into two parts. One is the inertial frame of reference, and the other is non-inertial frame of reference. The inertial frames are those reference frames, those points of references, which are either at rest, so the reference frame itself is not moving, or it might move, but move with a constant velocity or constant speed. So inertial frames are those frames that are either at rest or are moving with a constant velocity. On the other hand, non-inertial frames are those frames that are accelerating. So accelerating frames. Those are non-inertial frames, right? Now here we have two different examples. This is example one and this is example two. In both the cases, we are observing the motion of that tiny, tiny ball in the hand of the person, this ball, this and this. Now, whenever we are observing motion or rest, we have to observe it with respect to a reference frame. In the first example, the girl is the reference. So let's mark that. The girl is my reference. In the second example, the boy is our reference. This is our reference. So what is the difference between these two examples? In the first example, the reference frame is at rest. Although the object that we are observing, the ball, it's not at rest, it's moving, okay? So the first one is an example of an inertial frame of reference or a non-inertial frame of reference. Think about it. We've just seen that if the frame is not moving, it's an inertial frame of reference. So this is an example of an inertial frame of reference. What about example 2? We have a moving vehicle and you can see the velocity of the vehicle here. Okay, whether it is changing or not changing, you can figure that out. So now tell me, is the frame of reference or the boy here, is he at rest or is he in motion? If he is in motion, what kind of motion? Based on that, you can decide whether it is an inertial frame of reference or non-inertial frame of reference. See, velocity is constant, velocity is not changing. So this too is an inertial frame. Both these examples show you inertial frames of reference. We'll look into non-inertial frame of reference now. Non-inertial frames are frames that are accelerating. So instead of this v velocity, if we had something like v1 here and v2 here, doesn't matter whether v1 is bigger or v2 is bigger. So if we had a scenario where these two velocities were different, that means there is either an acceleration or a deceleration of the boy or the vehicle. In that case, such a frame of reference would have been a non-inertial frame of reference. Let's look into what is a non-inertial frame of reference. Now, the reason we are so concerned about deciding and what kind of reference frame do we have is because Newton's laws and all the equations that we are going to derive, they are not valid in non-inertial reference frames. So it is very important to decide whether we have a reference frame which is inertial or non-inertial. So can't we solve problems of non-inertial frames then? Now, that we'll discuss in laws of motion. There is something called a pseudo force which must be included to make Newton's law valid in non-inertial frames. We'll look into it later. For now, let's focus on what is a non-inertial frame of reference. As I said, a frame of reference which is accelerating. So here we have a vehicle which is accelerating. It has, let's say it has a constant acceleration. If this frame is accelerating, the boy inside it is also accelerating with the vehicle. So the vehicle is also a non-inertial reference frame. Or if you don't want to consider the vehicle, instead you consider the boy to be the reference. You can say the boy is also a non-inertial frame of reference. Choosing either the boy or the vehicle or the entire vehicle itself as the reference, now you observe the motion of this bob. This bob. This is actually a pendulum. This entire thing is a pendulum. If you're sitting in a car and the car has started accelerating in a certain direction, let's say towards east in this case, you would see that the pendulum, which was initially hanging vertically like this, will now tilt a little like this and make an angle theta with the vertical. Now, think about what is going on in the mind of this person. Now, this person is thinking, and I don't see any forces apart from mg acting on the bob. So, what pushes this bob further towards the left side? So now this physics student is trying to figure out why the pendulum moved towards the left side. And he can't seem to figure out the answer because the only force this person can see is mg acting downwards, or the gravitational pull of the earth. There is no force acting towards the left side. So why did the pendulum swing towards the left side? This person is not able to answer it. But a person standing outside might just be able to answer this question in a simpler way. This person is in an inertial frame standing on the ground. This person can see there are two forces acting on the object. One is mg acting vertically downwards, and the other is, since this vehicle is accelerating, so the point attached to the vehicle is this, there must be a force acting in this direction, or this point must be accelerating, and that's why there is that tilt. So this person is able to explain stuff easily if the observation is made from an inertial frame of reference. So do you see the problem? That means if we are changing the frame of reference, if we are observing the same motion from an inertial frame and then from a non-inertial frame, the non-inertial frame poses certain problems to us. To rectify this, we introduce a concept of pseudo force later when we study laws of motion in detail. Okay. For now, just know that all our reference frames that we are going to consider for 1D kinematics are going to be inertial frames of reference. Right. Moving on. So in the next session, we will start kinematics properly. We're going to look into what is position, how is displacement defined, and how is it different from distance covered. And then we'll move on to speed and velocity differences. Then finally, we'll try to understand what is acceleration and then equations of motion. See you in the next session.